An integer is assigned to each vertex of a cube. The value of an edge is defined to be the sum of the values of the two vertices it touches, and the value of a face is defined to be the sum of the values of the four edges surrounding it. The value of a cube is defined as the sum of the values of its six faces. Suppose the sum of the integers assigned to the vertices is 21. What is the value of the cube? So for this problem, let's try to get an idea of what's going on here. So let's say, for example, we assigned the numbers 1, 2, 3, and 4, just for example, to four vertices that share a face. So the value of each edge can be computed by adding up the numbers of the two vertices that edge is incident to. So this edge right here will have a value of 3, since 3 is equal to 1 plus 2. The edge that is incident to the vertices that are labeled 2 and 3, the value of that edge will be 5. Similarly, 3 plus 4 is 7. 1 plus 4 is 5. And then lastly, the value of this face that is that contains the vertices 1, 2, 3, and 4. The value of that face will be the sum of the numbers on the four edges, which is 5 plus 3 plus 5 plus 7. So the value of this face is 20. So for this problem, we know that the sum of the integers assigned to the vertices is 21. We're looking for the value of the cube. So one way we could solve this is we could just pick 8 integers that add up to 21 and find the values of each of the 6 faces in a similar way and then add them up. So while this will work, this is not the fastest solution, and especially because you want to find a faster way to solve the earlier problems so that you have more time towards the end. We're going to look for a faster way. So the trick here is that we can count how many times each vertex is going to be counted when we compute the value of the cube. So in order to do that, we need to figure out how many times is each vertex added. So suppose that this vertex that is facing me, suppose we'll make up a number for it. We'll call it x. And we're going to figure out how many times is x included when we find the value of the cube. So we see that x, this number x, we're going to count the number x 3 times when we find the values of the 3 edges that are incident to x. So basically what's going on is that every vertex that has a number on it, it's going to be counted 3 times when we find the values of the edges. Now we need to look at the so what can we draw from this? So we can find the sum of the numbers on the edges by noting that every vertex is going to be added 3 times. So this means that the sum of the values of the edges, so there are 12 edges on a cube. So we know that the sum of all 8 vertices is 21, and every vertex is going to be counted 3 times. So the sum of the values of the edges is 63. Now we can do the same thing by finding the sum of the values of the 6 faces in a similar way. So for every face, each edge is going to be added up to find the value of that face. So for example, this front face is going to be the sum of the 4 edges surrounding it. Similarly, the top face will be the sum of the 4 edges surrounding it. The main question is, how many times does each edge get added up? So every edge is adjacent to 2 faces of the cube. So therefore, we will add the value of each edge twice when we find the value of the cube. So therefore, we can state that the sum of the values of all 6 faces, there are 12 edges. Each edge, the sum of the numbers on the edge is 63. Each edge will be counted twice when we find the sum of the values of the faces. So therefore, the 6 faces will have a sum of 63 times 2, which is 126. And by definition, this is the value of the cube because this is by definition the sum of the values of the 6 faces. Therefore, the answer is D.